Good morning, dear students. Welcome to this session on pre-stressed concrete, Unit 3 of your syllabus. And we are talking about the loss of pre-stress out of six types of losses. And this one is the last one, uh, loss of pre-stress due to friction. This we have introduced in the last session itself. And we have a formula to calculate the loss of pre-stress due to friction, and it is available in IS code 1343 2012, clause 19.5.2.6. And we have seen an example also how we solve this, uh, no, the loss of pre-stress value. Okay. Now let us see some more examples on this frictional losses. Right. This example is a post-tensioned concrete beam. Whether it is told or no, not told, or whether it is mentioned or doesn't mention, you have to consider this as a post-tension member only, because the loss of friction due to loss of pre-stress due to friction happens only in post-tension members only. Right, the beam size is 200 wide, 450 deep, is pre-stressed by a circular cable, cross-sectional area 800 square with zero eccentricity at the ends and 150 at center. If you draw it just to some scale, right, the span is 10 meters. The span of the beam is 10 meters. And if you take this as centroid of concrete, zero eccentricity for the cable at this support, and 150 at the center, total is 450. Depth of the beam is 450. So out of 450, 225 is the half of the depth. So 150 may roughly uh, be around here. So this point. So you have to join this by a circular curve. Okay. So it's like a circle, part of a circle, that you have to understand. So it is like a part of a circle. So the cable may have a parabolic nature, or it can be straight, or it can be linear or circular. Okay, part of a circle, right? Cable is to be stressed from one end such that an initial stress of 840 is available in the unjocked end immediately after anchoring. You have to read carefully that the stress value given, whether it is P naught or Px. Okay, so this you have to understand that the stress value, pre-stress value 840, is available in the unjocked end, means it is not the P naught value. P naught value is the value which you induce by the jocking operation, means at the jock end. Okay, if it is unjocked end, means after losses, this is a value. I mean Px value is this one. Okay, determine the stress in the wires at the jocking end and the percentage loss. You have coefficient of friction given 0.6, and for wave effect it is 0.003. I mean K value is K value, and that is mu value. Okay, right. So this is how we read the values. So to use the formula like px is equal to p naught into 1 minus mu alpha plus kx. Okay, that is a formula. So mu times alpha, k times x. So you need alpha value. So you know what is alpha? Is the angle between the tangents drawn at the two ends of the cable. So even if you take the half of the beam, you can just double the value as I told you. So this is the angle that you need alpha. Okay, right? So this angle, okay, is alpha, right? So the angle between the tangents drawn at the support and at the center. So if you draw the tangent at the center, it will be horizontal line, and the tangent at the end is this line. So the angle between these two lines is alpha. Okay, so that you have to make a note of it. Okay, and the alpha to find if it is parabolic cable, we use dy by dx, like in the last session we have done. 4e by l is the slope value. As this is a circular one, you have to use the other way of finding it. Just extend these 2 points, okay, and you take this one, the horizontal line of this one. So it is like this is r square radius of this circular curve, and if you see, this is 5 meters, half of the span, and this is like r minus from here to now. This is the circle to this point is r. So whereas this value is 150 mm, so r minus 0.15 is this value. And if you can write the relation, r square is equal to, it's like a triangle relation, right angle triangle. So r minus 0.15 whole square, and 5 square is equal to r square. That is this relation. So if you solve this one, you will get the radius of the curvature 84, okay, meters. So 84 meters is the radius of this circle, part of a circle that is being given to you, right? Now if you want alpha, right, so either you can use this alpha, which is same as this one, because this line is perpendicular to this horizontal, and this tangent is perpendicular to this radial line. So any lines which are making an angle alpha, the right angles of those two lines also make the same angle. Okay, so that is this value, right? So alpha is found from this also. So if you write sine alpha, it is like opposite side by hypotenuse. Okay, right? 5 by 84. R is found, which is 84. Or else you can use any other relation tan alpha, like cos alpha, whatever it is. Okay, so sin alpha is direct known values. Opposite side is 5, and hypotenuse is r. So 5 by 84, that will be giving you 0.06 radians. radians. Now for the other half also the same angle will be prevailing. So that's why we can just double the value. Total cumulative angle between the tangents at the supports, both the supports. So finally it becomes 0.12 radians. So this is the way we find the alpha value which is to be used in this calculation. Right, Px is the stress at unjocked end, means after losses. This is 840. P naught is to be found, jocking value. Okay, so you have a formula like this: Px is equal to P naught into 1 minus mu times alpha is now known to you. K times x. All these values are given to you. Mu is given. K is given. So substitute the x in meters, the span of the beam. X is total span because you found alpha for the entire span of the beam. Okay, so that you will get this 0.898 P naught. So P naught value is Px by 0.898. Px is 840 Newton per mm square divided by 0.898. He is giving you 940 Newton per mm square. Okay, and the last value is 100 Newton per mm square because hydraulic jock created a stress of 940, and because of friction, its final value is 840. So because of friction, it is losing 100 Newton per mm square, and the percentage loss is loss of stress divided by initial stress, which is induced, which is 940 is created by the jock, hydraulic jock. So out of that 940, 100 is gone. So what is remaining is 840. So 10.6% is gone. Right, this is the example with a circular cable. Right, go to the next example. A cylindrical concrete tank 40-meter diameter is to be pre-stressed circumferentially by means of high-strength steel wire jogged at 4 points 90 degrees apart. If the minimum stress in the wires immediately after tensioning is to be 600 Newton per mm square, again Px is given, not the P naught value. A coefficient of friction is given, and K is not given, so you can avoid that part in this calculation because you don't have the data of K. Okay, maximum stress to be applied to the wires at the jock means find P naught value. The expected extension at the jock, what is delta value? I mean deformation. Okay, so you have a cylindrical tank, 40-meter diameter. Okay, so where there are 4 points which are 90 degrees apart. Okay, each on the periphery of the tank. So these are the 4 points, jacking points. So if you consider any one of the jacking points, say consider this one, this will be the length of the tendon, only this part of the tendon. Okay, so if this is the jacking end and this becomes unjocked end, same way this part also, this is jacking end, this becomes unjocked end. Okay, so if you just calculate for one part of the cable, that is similar for all the parts of the all other 3 parts of the cable. So consider this part, right? So Px is known to you, okay, uh, because the stress given is after tensioning, okay, after tensioning the value given to you, let P naught uh, e power minus mu times mu is 0.5 alpha. Alpha is nothing but you clearly know that if you draw a tangent at this end, it will be vertical line. If you draw a tangent, it will be a vertical line, and this is 90 degrees. So it is straight away pi by 2. So substitute for px, get p naught value, that is 1320 Newton per mm square is the stress that you have to develop uh, in the hydraulic job at this end of the cable. So when it goes to the other end, now when it now goes, when you read the value at the other end, this will be only 600, because all other now out of 1320, only left is 600. Remaining everything is lost. Okay, right. Average stress in wire is one end 1320, other end 600. Average is this, and length of the wire pi d by 4. Pi d is the circumference, one fourth of the value, pi d by 4. This is to convert that into mm. This much is the length of the wire. And if you want extension, I mean question B you are working out, is for question B, extension, stress by Young's modulus is the strain. Strain means change in length by original length. So this is stress value, average stress value by Young's modulus of steel into L. L is whatever you have calculated here, pi d by 4. So 144 mm is the extension of the cable. Okay, so that's a simple problem where the after tensioning the stress is given to you. Okay, and you have to find P naught value. What is the maximum stress to be applied to the wires at the jock? Okay. You have to apply 1320 at the jocking end, and you will have 600 remaining. Okay, and to find extension, as the stresses are different at two different places, you have to take the average stress. Okay, to substitute in this formula, like F by E into L for finding delta value. So F is changing from one location to the other, like the stress at this point is 1320 and the stress at this point is 600. Which value do you take to substitute it here? Because it is every point it will be changing, the stress will be changing at every point because of friction loss. So you take the average, right? Okay, going for the next example. Post-tensioned cable of beam 10-meter long is initially tensioned to stress of 1000 at one end. The tendons are curved so that the slope is given 1 in 24 at each end with an area 600 mm square. Calculate loss of pre-stress due to friction. Okay. So coefficient of friction between duct and cable, or wave effect coefficient K. Right. So there is another extension. During anchoring, if there is a slip of 3 mm, at the jacking end. Calculate the final force in the cable and percentage loss of prestress due to friction and slip. So it is combined, both friction loss and anchorage slip. Okay, let us find first the friction loss. So alpha given is 1 by 24 slope. So at both the ends you have to double it, double the value. Okay, at each end it is 1 in 24. So 1 by 12 is the total slope value. And mu times alpha, mu is there 0.00, 0.55. K times x, span is 10 meters. Substitute in meters because it is per meter, K value. So that is this value. Substitute in this, loss of pre-stress is P naught times 1000 is P naught value. Whatever stress is induced at the jacking end is 1000. Mu times alpha, K times x. These values you substitute. So you're getting 61 Newton per mm square as loss of stress due to friction. Now slip is given 3 mm. So delta is PL by AE. Okay, delta is equal to PL by AE. So P is the force in the cable that you want corresponding to the slip. So P you want. So 3 times cross sectional area 600 given of the cable, 3 times A E Young's modulus by L 10 meters. It is in 3 mm. So convert this into mm. Okay, this is in mm. So that is 37800 newtons converted to kilonewton. 37.8 is the force corresponding to the slip. Loss of force due to friction. Stress is there, stress is available, friction loss stress 61 multiplied by area will give you the force. So this much is the loss of force, and total loss of force due to friction and slip. So friction loss is 36.6 and 37.8 is the force corresponding to the P is the force corresponding to this 3 mm in to develop 3 mm elongation. What force is required, and this much is the force required. So the total value is 74.4. Final force in the cable. Okay, so the initial force is now 1000 into 600, so 600 kilonewton is the force. So 600 minus 74.4 is 525.6 kilonewton is the final force in the cable. Percentage of loss of pre-stress, and this is the force loss divided by initial force 600. So 12.4% is the final loss of pre-stress. Okay, right. So this is about the different examples based on friction, as well as the last example is combination of both anchorage slip and the friction. So practice these problems for all the types of losses, and we will discuss the uh, total losses to be calculated, which are allowed for in design, from the next session. Okay, thank you.